Welcome to the New Quantum Era. I'm Sebastian Hassinger. This is a special episode, our first ever recorded as a live stream, and it's a conversation I've been looking forward to for a while. I sat down with Will Zeng, co-founder and president of the Unitary Foundation, and Ziyaad Bhorat, VP of Imagination and Strategic Growth at the Mozilla Foundation, to discuss their co-authored white paper, The Open Foundation Quantum Technology Needs. Will has a DPhil in quantum information from Oxford and has spent years building the case that open source infrastructure is as essential to quantum computing as it has been to classical computing. The Unitary Foundation, which he co-founded in 2018, is a 501c3 that builds, governs, and sustains open source quantum software. Projects like MITIC for error mitigation, Metric for community-driven benchmarking, QTIP, and a microgrant program that has become, in Will's words, a faster on-ramp to quantum careers than traditional academic pathways. Ziyaad brings a different perspective. He has a PhD in political science from UCLA and leads strategic growth at the Mozilla Foundation, the organization behind Firefox, which has spent decades championing open source and internet health as a philanthropic mission. Mozilla's decision to engage with quantum computing is a deliberate bet that the field's foundations are still contestable, that openness can still win, and that philanthropic capital deployed now at high risk without expectation of return can shape what this technology becomes. Their paper makes a case that I think is both urgent and underappreciated, that the open source software layer of quantum computing is structurally underfunded. It falls into a gap between academic grants, which reward papers, and venture capital, which rewards products. And the consequences of leaving that gap unfilled could affect the trajectory of the entire field. The IBM Qiskit team reductions that happened recently are one data point. The broader fragmentation risk is another. Before we get into it, a quick disclosure. I'm a fellow of the Unitary Foundation. I believe in the work that they're doing, and you should know that as you listen to this conversation. That said, my job as moderator was to push past the advocacy that is present in the paper and dig under the surface, and I think Will and Ziyaad delivered. We recorded this and streamed it live on World Quantum Day, April 14th, 2026, and the video appears on the Unitary Foundation's YouTube channel. Let's get into it. All right, we are live with the first live streaming episode of the New Quantum Era. I'm Sebastian Hassinger, your host. I'm joined today by two really special guests. I'm very excited about this conversation. Ziyaad Bhorat, you're a VP from the Mozilla Foundation, and Will Zeng, I should say. We're old friends. I forgot to add your last name. Co-founder of the Unitary Foundation and venture capitalist and research scientist within the field of quantum computing. So welcome to both of you. I wanted to get you together because of a white paper you've both co-authored recently about the need for funding open source in quantum computing. So, Ziyaad, can you tell me first what sort of prompted the creation of that white paper?
Absolutely. And great to be here. Thanks so much, Sebastian. And great to chat as well, Will. And also on this auspicious day of World Quantum Day. We at the Mozilla Foundation are always looking for what is on the horizon, how to learn by doing. And we saw an opportunity to be involved in open source quantum computing at an earlier phase than I would say some in the philanthropic space had been involved in AI. And so that was a good comparator for us. Reaching out to, speaking to Will and the team and other grantees in our portfolio around open source AI, we quickly realized we need to be doing something similar for the field of open source quantum. And so that was really motivating our foray into the field, is also very much learning. learning by doing, and an earlier point of intervention. So I want to emphasize that as a kind of rationale, and that comes through
Mhm.
in our paper.
Yeah. Yeah. And I imagine Mozilla Foundation sort of the 800-pound gorilla in open source. The motivation for partnering with Mozilla is pretty clear, but the core sort of thesis of the paper is that there's a funding gap for open source within quantum. Um, what is the nature of that funding gap from your perspective?
Yeah, look, and again, Sebastian, thanks for having me on here. And maybe I'll just add kind of working with Mozilla is another example. Like I've been in quantum technologies for a long time. Like it's the field that I grew up in, and we can learn so much from the first round of classical computing, first rounds of classical
Yeah.
computing. Um, a lot of what we get to do in quantum is learn from what happened in classical computing and try and add interventions early when things can be really, really high leverage. And that's why the Unity Foundation is now kind of almost coming up on its 8th year, and trying to build that open source culture in when the field is small enough that we sort of all still know each other. um, the goal is to grow it to where we don't. And so if we can build that stuff in earlier, then we'll get all the benefits that come from it as the entire industry matures. Um, Now, I would say that the impetus behind the white paper is not just about a funding gap. It's about a funding gap plus other things, because public goods and open source aren't just about money. So when you have a new industry emerge, there's some things that can get built by existing structures. There's the academics are really great at making papers with new ideas, like or corporate research labs. There's research infrastructure for writing papers, and then there's stuff that venture capitalists can fund. I'm one of them. There's things that are even long term deep technology shapes, but there's other things in industries that exist that aren't that. That's these public goods, networks, standards, benchmarks, open source software, compilers, training materials, just like person to person education networks. All this kind of stuff we know is really crucial glue for making an industry work. And when you've got a new industry like we do have in quantum technologies with a bunch of different products and companies all relating to each other, you have to ask, where is that public glue, public goods glue going to come from? And that's what we've been trying to foster at Unitrade Foundation with a lot of folks in the ecosystem. And how to do that is what we want to learn from folks like the Mozilla Foundation, or kind of anyone really who's been through this kind of transition in building an industry.
Hmm. Hmm. And Ziyaad, you mentioned this from the Mozilla perspective as being a learning opportunity. So, what I mean, I mean, obviously, the field of quantum is a learning opportunity for everyone. I'm certainly one of those who's
Yeah.
been on this very steep learning curve in quantum technologies for a number of years now. But I'm curious what you saw institutionally as sort of the comparison points. What were the things that looked familiar to Mozilla for this stage of quantum? Because obviously the unfamiliar parts are pretty obvious. So what were the comparison points to other early stage technology markets that you have been active in all the way back to the browser?
Yeah, it's a great question. I think some of the things, and I'll share a couple of anecdotes that were precursors to us really circling and finding great partners like Unity Foundation for this work. Is that we started to see communities develop across the world around quantum that weren't even necessarily technical. They were artistic communities, right? They were philosophers, they were theologians starting to think through what is quantum mechanics, what is expression of quantum, and talking about definition of being and artistic expression. And that's usually a signal that something big is happening in society, right? And we need to be involved in it. And so the community centric approach, really, that started to form around quantum was an early signal for us needing to take a look into, correctly put, Sebastian, unfamiliar territory. Many folk at the foundation, and myself included, do not have a technical knowledge of quantum technology. And so we need to develop that capability, plug into those communities, grow them, and strengthen them as well. I think the other anecdote that I want to share was, again, to the comparator of AI, there's a lot of high level interest from governments, non state actors, in quantum computing right now. And when we had discussions around AI, quantum computing was often folded into the category of emerging and frontier technology. And as an advocate for open weights and open source AI in particular, we thought we naturally had to confront the question of, well, how do we think about the open source quantum question? And so it came up in that, both grassroots and grass tops intervention spaces. And then the final thing I will say is that, to Will's point about risk and venture capitalism, it also has to do with how you think of the role of philanthropy in general. We see at the foundation in particular, we see our role as deploying philanthropic capital at a high risk stage of intervention, right? Really, when you can be experimental, you're not looking for kind of capital returns. You're looking to demonstrate that something works in the field and can be a model for it. So it's an earlier stage. And so for us, it just felt like the right moment to be engaging.
That's really interesting. And I guess that goes back to what you were saying, Will, about it's not just about capital or access to funding for open source projects, but this broader sort of cultural or societal engagement with the topic across the board. I guess, I mean, you list in the paper a number of supporters of the Unitary Foundation already, the NSF, DOE, IBM, Microsoft, Amazon. Um, Beyond that core group, what's sort of the next tranche of supporters and engagement that you'd like to see more broadly to start to grapple with those sort of broader issues?
Yeah, honestly, the next one we want to go for is everyone who builds classical open source,
Mm,
because they have a lot of skills that are super relevant. And I think, look, like people don't necessarily have a sense of how early quantum technology is. Like you see world leaders pop up there and say quantum and AI, and or something. You even put quantum first sometimes.
yeah.
And like we're all super excited that last year there was more than 10 billion in private investment in quantum technology. Now, before 2020, that private funding by VC was like less than a couple hundred million a year.
Yeah.
It's sort of de minimis. So we're really excited that we've gotten to 10 billion, but the US spends what, 30, 35 billion on potato chips every year. Um,
That's humbling.
around, like there's a lot of room to grow.
Yeah.
And sometimes people don't realize how much leverage they have in taking skills um, that already exist and bringing them in. And maybe I'll give you an example, because that's kind of like how the Unitary Foundation got started at all. So about 8 years ago, I was running the software and applications team at a company called Rigetti Computing, which is one of the first quantum computing companies. That's now a pretty big public company. And we were releasing our first software. And we decided to do open source software for a couple of reasons. One of them that really applied then and applies a little bit less is just credibility. Like nobody knew what a quantum computer was. And so you selling this magic black box that no one knew how to program. They couldn't see the software and they didn't understand it. Like wasn't really going to fly. So we needed to white box it. And so, it's different, but it's in Python. I
Right.
guess.
Yeah.
With
Not
some,
that different. Yeah.
yeah. You have to think about things differently, but you can learn it. It's a little linear algebra, just add some complex numbers, probabilities, all that stuff. And when we did that, some surprising stuff happened. So we got contributors from the usual suspects, whatever, Harvard, MIT, Caltech, people that we kind of knew. But then people started closing bugs on GitHub who were hobby software engineers in Eastern Europe, an Irish high school
Yeah.
student, an Indian master's student who was really into quantum and had nobody to talk to. And yeah, they weren't coming up with like some breakthrough computational complexity result with a new algorithm, but they were fixing real bugs in real software. It was Python. The docs were bad. Like this is really useful work. And that opened up my eyes to just how accessible a seemingly inaccessible technology can be if you give people entry points. There's billions of people on the planet who want to do exciting and interesting things, and building quantum technology is one of those. And if you have enough motivation, then you just need to provide some on-ramps for people to cross over. And so when I talk about it not just being about funding, like the funding is actually downstream of the people. What we really want are the people and kind of who are doing this and building it. And there's a lot of ways to get there. There's in-kind contributions, but of course, money helps too.
Yeah, and I suppose, I mean, what you just touched on, I mean, Unitary Hack demonstrates that every year, right? You bring in people who don't necessarily have specialized knowledge in quantum at all. They're into open source software development, and they can close bugs, and they can, yeah, exactly.
We
So
can just talk a little bit about that as an example too. So, there's a lot of people use hackathons as a way to get people exposed to stuff. And we do hackathons in a little bit of a different way at Unitary Foundation. It's called Unitary Hack. I think we're on like year 5 now. I mean, it's really taken off. And it's for 2 weeks, we put up bug bounties. So we go to maintainers of some of the important open source software that we know. I think last year we had maybe 30 or 40 different projects. We go to the maintainers and they have a few needs, right? They need issues, features built, bugs, resolved. And then they also want to connect with people who would contribute longer term, not just like one transactional thing. And so what we do is we allocate to them some bounty budget in that 2-week period. And then they can put that budget on whatever issues on GitHub they want people to solve. And then people sign up from around the world, 500 we've had, more hundreds who've joined, and they come together and then close issues and get paid from wherever. And look, like it's kind of surprising where you find people, and money goes a lot further in other parts of the world. And it's also an accountability mechanism. Like even if it's not necessarily like going to be your full-time job to close bounties on Unitary Hack yet, it shows that your contributions are being valued by the people who you want recognition from, which are the maintainers, and us. And so that's something we do once a year now. I'd love to do it multiple times a year. Frankly, we want to get to a world where people can exist as full-time quantum open source developers in the same way that they exist as, developers on Linux or in Apache, or like they're kind of freelance full-time open source developers who can get paid doing that. And we really need that in quantum because even though the hardware is getting better, the software is just still a huge gap that needs and we can talk more about this, but like there's a lot of software that doesn't exist that needs to get built.
Yeah. Yeah. And Ziyaad, listening to what Will's saying, I mean, to me, that sounds like addresses directly the need for a quantum workforce, which is workforce development is sort of central to all of the national quantum strategies that I'm aware of, even regional ones. From your perspective, is that a big part of the pitch, I guess, for philanthropic backing, is that this is a new set of job, opportunities, of career opportunities, career paths, especially at a time when the pathway for software development is in flux, let's say, because of AI and its impact. Is that part of the appeal for quantum at this point for Mozilla and its supporters?
There's definitely a question around the future of work and where we see the gravity drawing people in from, let's say, current development paths and current developer paths in particular across the spectrum. But what I would just like emphasize is Will's point about creating on ramps. I think it's less about career workforce planning and more about community development. Because communities will create the opportunities for a workforce if you give them those on ramps. And I think it's really about starting at that intervention space first, rather than trying to shape a future career force, to be honest, in our form of intervention, because that's how we've worked. As Will has described the hackathons, bug bounties for Firefox bugs in particular is a clear example of how this has worked in practice. What that tends to do is build strong community around a field, an area, open source in particular. And then as a result, the radiating effect is workforce development. So I would actually put the community element first, and then workforce second, because there's a lot happening in the workforce space right now, as we can tell. I do think, however, to your point, that when we look at national and international mandates in the quantum space, there is an acceleration to thinking through, okay, what critical skills do we need to develop, and how do we do so, and how do we create the educational off ramps to do that. But and that isn't necessary, but it's not a sufficient component. If that work is happening in silos, if we're not creating those integrative effects across different communities, even across the world, then net we're going to just get there slower. We're just going to get there in a fragmented manner. And I think that a part of this is actually seeing the community for what it is and bringing it together within the space. And that's what I'm super excited about in doing this work with Unitary.
That's great. Yeah, I mean, so it sounds like, in a sense, both of you, you're emphasizing community building as a way to accelerate or create a more accretive framework for progress. And the urgency you just mentioned, Ziyaad, I mean, in the paper, you call out the sort of recent advancements around the efficiency of implementation of Shors, Shors being the factoring algorithm that can potentially crack all codes. The sort of magical, it's almost like a MacGuffin. It's a plot device in quantum computing, I think.
Yeah,
But
no, but it's not. It's not a plot device. It's kind of an inevitability. Like we're at
yeah, oh, for sure.
a timeline, but like
Yeah.
something really weird would need to happen where this didn't occur at some point.
Yeah, and at some point, that future point seems to be getting reeled in closer and closer to the present day, right? I mean, you've got Google's 20x efficiency gain. You've got Iceberg Quantum with Pinnacle saying they can get the number of physical qubits down to 100,000 for RSA 2048, and Oratomic just coming out with something like 50,000 or 10,000. I think it was even smaller.
Depends on how
It's
much.
incredible.
But yeah.
Yeah, exactly. Yeah, there's always the fine print is always nuanced, but at least at the headline level, that sounds like enormous acceleration. Is that sort of meant as a as almost like the prod to get the national level, the philanthropic community, the sort of the motivation, the top level to really treat this seriously, and really put some weight behind the development of that community that's required to fill some of those gaps?
Yeah,
And that's for either of you.
no, I feel like, to be a little reductive, it's kind of like, what kind of future do we want
Yeah.
for quantum computing? Do we want a future where quantum computers are developed by secret government contractors with like specialized PhDs who have top secret security clearances, and they, mostly keep them under lock and key? Like, is that the future we want? Or do we want a future where quantum computers are built and developed in the private sector, competing to provide economic value to everyone around the world on a bunch of applications, and we get through this upgrade so that the threat they have against encryption kind of goes away? And look, that second future, like it's almost hard to talk about the potential there, because again, it's not just like one product. Like if you thought about the potential of computers back in the 1950s, you would have missed a whole bunch of benefits that they brought to the world. And we talk about the white paper, right? The UK government sort of took the approach of, let's disassemble the computers that were built at Bletchley Park. They're classified, keep them under lock and key, because they're for cryptography. And if you took the more expansive view of how do we get these in the hands of people who might think of how to use them in ways that we can't think of now, and that involves openness and on-ramps and accessibility, then you get huge futures where there's a lot of benefit. And that's the world that we want. And so we want to put our thumb on the scale to make that happen.
Yeah, I would agree with that 100%. I mean, every day I open up the news and I'm like, okay, this is the new thing we should be afraid about. Is it mythos today? What is it going to be tomorrow? There's something that we need to be protected from in terms of the boogeyman of like breaking all security. And so to Will's point, we shouldn't be reactive in this space. We should actually put forward an affirmative vision of what that future should look like and drive towards it, because otherwise it will be built in secret. And I think that that's not the way to do things. I mean, it's very clearly not Mozilla's way of doing things, and we have a long track record of saying so, but it's also just not the way of doing things, because then the future is dictated in private in rooms that no one is privy to. So an open and expansive field in this space is something that I think is necessary, and an affirmative vision that is positive, that is not based out of fear, because so much of this fear is driving kind of policy imperatives. That just needs to change.
And kind of, I don't want to pick up what you mentioned, because in the last couple months, and it's going to keep happening. People are coming up with improved estimates that make it easier to use worse quantum computers to break encryption. And like, there's a lot of asterisks and things that people have put out, but it's going to keep improving. And the hardware itself is going to get better. And it's so important that people are open about those results, because there are more closed groups that have been studying this for a long time and know that in more detail. Being open about these resource estimates, and this is where software can play a big role, and it's where we're sort of looking for more of the microgrants we do. It's to do open source resource estimates, to do open source development of the error correction overheads and architectures of the things that matter, that move those resource estimate numbers around by a lot, so that the world can just be aware of what the actual risk is. And these last few open publications have moved timelines for post-quantum upgrades publicly for Google to 2029, and Cloudflare's now followed to 2029. I mean, the US government for secure systems has had it to 2030 for a few years. We'll see if they bring it in even further. And so the more aware people are openly of the risk, the sooner they can just do these upgrades and we can just be done with it. And then we can focus on all of the great things that quantum computers can do for us in terms of developing new materials and new chemicals and maybe improving machine learning. I mean, there's all these things we don't even know, but that's where we want to get to.
Yeah, yeah. No, the openness argument is a really powerful one, and what's striking to me is there's sort of two distinct, faces to it in this particular context. One is, as you say, sort of the upgrade, the threat to security, the need to figure out how to secure communications and data against this new attack that was, theoretically impossible until Shor came along, and practically impossible until
Always knew it was a risk, but and there's still a
Yes.
risk. Regular computers can do it, but anyway, whatever. Now we
true,
know.
true. True. No, I call it a plot device because when I talked to Peter on I think the 30th anniversary of the algorithm, he was telling me that there's so many weird things about the discovery of that algorithm. One is that it was just after April Fool's, and on the Usenet on April Fool's, there'd been a post about a pretend Soviet technology that could crack all codes. And then he first presented it on stage, not the first version, but the factoring version, at a seminar that Edelman hosted. And Edelman was the scientific advisor on Sneakers, the Hollywood film 3 years earlier that had a technology that could crack all codes. It's so bizarre. But anyway, there's that whole threat envelope way of seeing things.
Right.
But what you said, Will, is that also openness keeps technology in the public sphere, in private markets, not public, not the defense or an intelligence community kind of spheres. And I think that's a more expansive kind of context beyond the immediate threat. So do we think that the threat envelope perspective is needed to drive the motivation for the more nuanced reason for being open with technologies?
I think they both help. Look, they go together. And look, like I want to give another important thing about this Google announcement is actually for each one of these disclosures, the people who disclose them have started to comment more specifically about doing this responsibly. We want to release a credible new lower bound for how good of a quantum computer you need to break encryption, but you don't necessarily want to give people a blueprint because we want to have enough time to do the upgrade. And so Google did this really great thing where they actually released a zero knowledge proof that they had the circuits of sufficient size that was able to break it without releasing the details. And guess what they used to build up that zero knowledge proof and release it publicly? A bunch of open source software from the classical crypto community. And so these things kind of all stack in kind of interesting ways.
That's interesting. And so, when Will talks about the need for a lot of maturity in the software stack, the kind of toolkit that Google just used from the open source classical crypto world, Ziyaad, does does the metaphor of a quantum Linux, does that resonate for you and for Mozilla?
It does. I think we're, from a Mozilla standpoint, still ways away from developing that. As we say, learn by doing, and a lot of our work is just focused on making sure we're kind of connecting communities in the space right now. But it tracks how we generally think about the role of open source in general. It is in the enablement layer. It is not in tension necessarily with proprietary offers and platforms, products, and tools and systems. But it should be the enablement layer for a lot of what we see out in the field and in the market in particular. And so to develop something like that would be a dream. To have something like that would be a dream, but it should be the enablement layer rather than something that is an offshoot down the line.
That makes sense. The one thing, that phrase is compelling, quantum Linux, but the thing that occurs to me is also Linux succeeded in large part because it scratched an itch for a large community
Yeah,
of developers. We don't have, as you said, well, in the quantum community at the moment, we all know each other pretty much. The goal is to get to the point where we don't know each other. I like that framing. But does the does the Linux metaphor hold in that kind of smaller, sparser community, or is a different sort of approach required at that stage?
Yeah, I mean, I wouldn't try and like read into the specific detail. It's not like we're going to do exactly Linux. Operating systems look different. Like we're in a world where maybe all the software is going to be written by AI. To me, it means like Linux is significant software for the industry. In many ways, the standard, obviously, going through a branching, but a standard critical piece of software that people need and use that's open source. And we want to have, and it doesn't have to be one piece of software. It could be a bunch of things that relate to each other. That's what we want to have, because that is what enables a lower activation energy to start new companies, because you can use that software. It makes it easier to study and develop and do research. Maybe another example, like we had a microgram project pretty early on in Unity Foundation called pi matching. So when you have a quantum computer, it has a bunch of noise, errors accumulate, and you want to correct the noise. You take some measurements, and then you try to infer using something called a decoding algorithm on a regular piece of classical software what corrections you need to make to fix the errors that have accumulated in the quantum computer. And there was this pretty, well-known algorithm for doing decoding and like a code that people like to study a lot, but the only available implementation was like under this software license. I mean, it wasn't crazy expensive if you were a company, but particularly at the time, several years ago, like not everybody was in a company. They were researchers or you were some graduate student, and like the process of like, how do you get budget to sign up and get this license, et cetera, et cetera, et cetera. And so Oscar Higgett applied for one of our micro grants to build an kind of both better in Python and open source, easy license implementation of the algorithm, because the algorithm's been known for a while. And that unlocked a whole bunch more research into quantum error correcting codes. And the field of error correction is very big right now. And a lot of them use a bunch of open source software, some of it from our microgrants, some of it things like STIM. And I'm not going to say that's like a million developer community using Linux, but kind of the core tools for studying error correction are now based on pieces of open source software. And those will go into the software that runs the quantum computers to do the error correction. And if that's more open, then it'll advance faster and more accessibly. And so all built. So it comes back to like what Ziyaad was saying earlier, like intervening early is a lot less expensive. When a lot of people in philanthropic capital, it's like, how can I spend my money somewhere where someone else isn't going to step in and just do it, and where it's likely to have a big impact right now.
yeah.
And if we are in a world where the only quantum computers are under lock and key in some MISO silo, pulling them out is going to be really expensive.
Yeah. You touched on something that also is focused on in the paper, which a condition in the quantum market right now where people who may be writing code are kind of stuck between the academic world and the startup world, or the VC-backed world, where the academic world rewards, and that's NSF funding, DOE funding, Horizon, Ochre, all the various public sector sources of funding. they reward publishing papers, research papers over running code, and then the venture community, the private capital community, rewards products and paths to ROI over something that of sort of more broad social good. Ziyaad, you mentioned sort of, the challenge being the technical depth of quantum at this stage. Are there areas from Mozilla's experience that look the same in terms of being stuck between academia and private capital, or other sorts of, valley of death type constructions that open source and Mozilla can help sort of bridge?
Yeah, and it's something we've actually explicitly oriented around. At the foundation, we now have an incubator aimed at the Valley of Death, focused on product community fit instead of product market fit. So, just a little bit about how our intervention space is now positioned, and what we aim to do at the foundation in particular. We've seen this with AI, right? I keep coming back to it because, unfortunately, it is the comparator. Fortunately, one unfortunately, it is comparator right now in this broad tent bucket of frontier tech. So we do see that with AI in particular, where interventions, in private markets are sometimes accelerating faster than the capacities that we see at universities. There's talent implications between the two as well, playing out in all kinds of ways, some of them healthy, some of them not so healthy, changing incentives to get involved in higher education, for example. So there's a lot of distortionary effects that you can just even learn from in the case of AI. And that's why I think makes it such a fertile and a fantastic space to be involved in the quantum conversation, is because at least, different world, but there are some analytic components that can be carried forward. And so what I mentioned earlier was not just only, private markets, venture capital, academic institutions, but to really have a community, you have to have a sense of purpose and shared belief, right? And so that's why I think, like, even the artistic communities that are embracing this are doing so much to translate what is pretty heavy technical understanding into self-understanding. And so when you start to have that kind of be a part of this broader tent community, you actually start to see that form in a more cohesive way. And so that is actually a learning that we had with AI as we start to see artists get more and more involved, from skepticism to kind of self-understanding. Communities are built when you have this broader tent of folk who are bringing kind of the full picture of the system together. So that's what I would say in terms of how we've seen and what the comparators are. But it's not only, in the AI space. There are some fantastic things also happening in VR and XR in particular, which I'm talking about on Friday. So there's a lot of new tech out in the space with underlying social and societal change dynamics. And so it's just a really exciting time, to be honest with you, to be involved. And I think quantum field and open source quantum is just such a ripe opportunity for asserting a positive vision and just kind of sticking to it. That's what I'm so excited about.
That's great.
And
That's great.
sticking to it is complicated too. I mean, and not necessarily because it's like morally difficult to keep doing a good thing, but you have to keep
Yeah.
evolving. Like we started around a microgrant program 8 years ago. The quantum technology industry is totally different than it was 8 years ago. It's going to be totally different in another 4 or 5 years or 8 years. And one of the reasons we're teaming up with Mozilla and putting out this white paper is to put out the call that actually things have gone pretty well so far. I mean, of course, we would have wanted quantum to be developing faster, and it could always be faster. But it's gone pretty well. We've made pretty solid progress. It looks like progress is going to continue. But if we want to stay on this track of developing big, valuable economic impacts across industries with quantum, then us at Unitary Foundation, the open source community, is going to need to keep up. Like we're also going to need to grow. And we're not able to do the things that the companies are doing now, like go public on NASDAQ, to raise enormous sums of resources in order to do that. So we want to put out the call that we are looking for partners to help support us continue to grow along with the rest of the industry. And that includes a lot of those companies who are now going public,
Absolutely.
who are our partners.
Yeah. 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 I mean, I want to dig into a bit to Unitary Foundation because I think it's really an extraordinary story. You mentioned microgrants. I think it's 150 plus microgrants over the 8 years. They're across something like 30 countries. About 50% go to underrepresented, groups. Um, Among the projects, so the headline projects are MIDIC and Metric and QTIP and others. What do you think is the highest impact project that Unitary Foundation has supported, and how is that measured? How do you measure that internally at Unitary?
Sure. I mean, it varies because there's different ways of measuring stuff. So I talked a little bit about pi matching as an example of open source. There's a couple other pieces of open source software. There were these projects around this stuff called the ZX calculus. It's like super mathy, um, graphical approach to compiling that ended up being useful for error correction. And we funded some of the original packages that, like this one called PyZX, that took some of this funky mathy stuff that was like a little bit on its own and made it again into a Python package that you could just put into some compiler workflow that you had. And then people realized like, oh, this actually works pretty well. And you can sort of black box the mathy part of it. And so there's been a bunch of stuff around ZX. It's in several of the corporate um, software stacks and compiler stacks. It's relevant for error correction research. And so that's a good example of the scalability of the kind of stuff that we can fund. Like software, not just like it doesn't just make it open, it makes it composable. Like when you take that's in a paper and you put it into a library that I can just import and play with instead of necessarily having to learn it all, it's like an on-ramp to that idea that can then help it scale. And so
That's where you can see the accretive power right there, right? I mean, it's like once that research paper is turned into a reusable library of code, then the next person doesn't have to, they can just start from that and move forward instead of having to recapitulate the work.
yeah. And they can, can convince themselves that it's worth learning because they can just try it out with a few lines and be, oh, this kind of worked. Now I should learn what it does. Which is how people really operate. And there's other kinds of things we fund too. I mean, we funded this organization called QWorld that's become its own standalone nonprofit. They've got they build up educational materials about quantum programming and quantum software and teach courses. And they've I actually don't even remember, like thousands of students have gone through this in like 20 countries where they've established different chapters. Um, and those there's sort of two ways to think about the impact there. One is just like how many people did they talk to, but it's also like how many people from that community or from other micro grants then went on to work in the quantum computing industry. And there's a lot of these. Like our micro grants are not that big. They're $4,000. Usually they're kind of 6-month projects. It kind of varies because people propose different times. But 6 months and $4,000 is a lot faster on ramp to a meaningful job in quantum technology than a bunch of other approaches. And we just have too much to build to be credentialist. To say, oh, go get a PhD, which is not even necessarily the thing you're supposed to like.
Yeah.
There's a few places that do research in quantum software, but like most quantum software, a lot of the front lines of building it are in these companies, and there's no class to take that teaches you how to do it. You just got to go do it. And open source software is a place to show that you can do the real thing. And there's no gatekeepers. Like anyone can go on the GitHub, solve an issue, prove that they can do it, and get a job more quickly than they might think.
Ziyaad, I see you nodding, and I imagine Will is preaching to the choir with you. I mean, these sound like they're like 100% aligned with sort of Mozilla values and strategies, I would assume.
I mean, if I have to tell you, it was part of a multi-year petition on my part to make sure we got involved in the space. It should not surprise you. I reached out to Will like years ago, and I was like, "I love what you're doing." It's very early stage for how we're thinking about some of the things that are immediate right now in the ecosystem. AI just being one of it, right? Like, there's a lot going on in the tech space right now, but I see the opportunity space. I see what you're building. The principles are real. They're very much aligned. How do we plug in? And so it took some time, but here we are, and I'm just so grateful to be a part of it.
And I think the kind of thing Mozilla is recognizing with their new incubator, that there's kind of this gap. We kept talking about this gap between kind of like research and like sort of venture fundable company stuff. Other people are recognizing it too. There's been this movement around focused research organizations, a lot of stuff Convergent Research done. And the NSF has put out this call for these things called tech labs, which are to get some of the benefits of a startup structure, like stable funding, sort of management and founder driven, but not for something that's going to become a business, something that's going to produce like public goods technology. I think the tech labs initiative is fantastic. We wrote an RFI at the Unitarian Foundation about how it could apply in quantum, particularly around quantum software. I think there's a big opportunity there. Um, I will say, I think we were all expecting their call for proposals to come out last month, and it has not come out. So I really hope. I think it's a great initiative. I hope it happens. I hope it happens soon.
It wouldn't be the first thing to be moving on a slightly slower timeline in the U.S. government in recent days. So I'm still hopeful.
Yeah, indeed. But this is exactly the sort of thing that people, I think sometimes voters wonder about, like, okay, there's a bunch of great PDFs that are
Right.
like have a lot of great ideas in them, but like how do we get those into stuff that I see?
And
Janice could do that.
the Unitary Foundation also has a long history of leveraging public funding. I mean, I think one of our first conversations was around the DOE funded, if I recall correctly, effort that turned into MIDIC. And you've also got Metric, which I think has had some public sector funding. You mentioned composable. That's why I'm bringing up those two examples, because they're both frameworks that are very purposefully meant to be expansive and open lower the cost of entry to a particular area, error mitigation with MIDIC and benchmarking with Metric. Why do you think Metric has done a major release, which makes it even more, I think, accessible as an on-ramp? Why does the Unitary Foundation think that benchmarking, either benchmarking itself or that framework, that approach to a framework in general is important at this stage?
Sure. Maybe before I talk about benchmarking, I'll just talk about some of the public grant and collaboration stuff. Often we find great partners, and they've got a lot of great ideas. They want to write great papers, and we say, look, why don't we help you take the paper you built an MVP with some sciencey code for, start plugging these together into something that other people can use and build upon, be that another researcher at some other university or a company or yourself in 4 years when you like forgot. um, and and so kind of upgrading into composable software, because a lot of the fantastic academic and research ideas, because there's tons still, like quantum information is the fastest growing division of the American Society of Physics Society. Like there's tons of research ideas. We just want to start accreting them into composable software. So that's a role that we play a lot. It's great that funding agencies and some philanthropists and private sector entities like recognize that value, because it's been super high leverage. Benchmarking is kind of its own sort of complicated public good. Like at a high level, all these stakeholders like want to know how quantum computing is doing. Like, it might be somebody who's worried about getting decrypted, might be, policymakers who are like, we keep putting money into this. Is it working? Could be users who are saying like, when is this going to be useful for my use case? It might be someone who's a software engineer in AI who's going, I kind of want to do something new, but is this quantum thing like happening or not? Like, is it improving? And benchmarking is hard in quantum because we have no standards really. I mean, we're better than we were 5 years ago, but there's not like a flops. There's not like standard numbers that like everybody runs. And part of that's because a lot of the research community is incentivized to come up with new benchmarks, because a new benchmark gets you a novel paper. Running existing benchmarks is kind of by definition not the thing that's going to get published. So there's this gap. And so we've been trying to help fill the gap. And the approach we've taken with this suite of metric tools, the website's metric.info, is to just start posting publicly sort of like Geekbench style runs of suites of open source benchmarks. So the software's called Metric Gym. There's a bunch of benchmarks in there. We know they're not perfect, but we think they're correlated with improving progress. We're looking for feedback on how to do those benchmarks, what the benchmarks should be, how to make the benchmarks better, but also people who want to help us run them on new bits of hardware. And then we kind of compare and roll them up into this sort of summary score. But of course, you can dive into it in more detail on the metric info website if you have particular things you care about. And so what we're going to do over time, and we work with a lot of people in the ecosystem around how to do this, is we'll keep running it. And we'll keep running it on hardware and show that things are getting better and kind of at what rate. And then we're going to keep upgrading the benchmark suite itself. And maybe I'll just kind of end with like one, I think, good analogy that Scott Aronson made for like how benchmarking can go pretty wrong in quantum computing, which is that a lot of people with respect to cryptography have kept saying things like, well, like what's the biggest number you can factor? And the biggest number we factored on a quantum computer is tiny. Maybe it's 35. And did we we kind of cheated or like whatever.
Yeah. I think 21 end to end is the largest.
Yeah. So, and like that number is not like, nobody's really running small examples of shorts. Like we're not even trying to do that. And Scott Aronson summarized this in a way that I think is very apt, which is like going to the Manhattan Project in 1943 and saying, have you even made a small nuclear bomb?
Right. How many atoms did you split today?
How many atoms?
One?
Yeah. Because that's just not how it's going to work. Like we're going to get systems that are, at like fault tolerant and at scale. Right. And then like pretty quickly, the key size that you can do is going to grow. And it's a little binary. You hit a key size that's practically relevant for cryptography or not. And so picking good benchmarks is important, and explaining the context around them to the broad stakeholder community of people who look at quantum technologies is even more important.
Yeah. Yeah. I like that example because, as you said, benchmarking is complex, but it's also, it strikes me as something that uniquely an open source community is well suited for, right? Because if a vendor is driving a benchmark, you always have to question why that benchmark from that vendor. Yeah. If there's a commercial effort to do it, there's always going to be that question of what's the motivation. And in an open source community driven effort like this, the motivation is the exploration of the question without some sort of preconceived notion of what the answer is you want to get out of it, right? I mean, that seems sort of like a canonical example of why open source. So I want to get to the point like where, the white paper is great. It's a great framing mechanism. Are there specific, like Ziyaad, when you think about, program officers at major foundations who may have budget available, like what's your sort of pitch to them? Where should they put that money if they're interested in exploring the impact that quantum technologies can have, or open source can have for quantum?
I have been saying, so this is active conversation with colleagues as well. So great call out there is do not be afraid to experiment. I think in this moment in time in particular, we can sometimes be very slow in philanthropy. And we're doing ourselves a disservice to be slow, especially in a space that really warrants experimentation. And so deploying funds into the field is our way of showing that something can be demonstrated, and we should act accordingly. So that's what I would say to my colleagues who have budgets. This is an exciting field. We've seen what happened with AI and the kind of a consolidation of power around it in frontier labs and hyperscalers. Do we want that world? We're actively working to address it now, almost after the fact. But do we want that world in quantum? It's not a one-for-one comparator. We know that. But there are enough analytic components where we should say to ourselves, well, what if we had acted earlier and more quickly and with more conviction about the fact that, we're not afraid to experiment. And so that's what I would say is like learn by doing. It's really important to unlock that catalytic capital and learn by doing.
And maybe add, and I'm going to say something that's a little bit on the fear side, but as much as people worry about the consolidation of AI, it could have been a lot worse.
Yeah.
A lot of the origins of open source machine learning software like go back a long ways. Like a lot of it was open source. Like there's reasons there are open models at all. Didn't have to be that way, and it's not guaranteed to be that way for quantum. Like some people made that happen in AI. Maybe we want more, but like, it could have been even more closed. And so that's worth keeping in mind too.
Yeah. Yeah. Very good point. And Will, continuing with you, like if you mentioned the role of public sector, the NQI is coming up for reauthorization finally. Are there specific policy asks either in the US or in Europe or just globally that you think would help this particular moment in quantum technologies?
Yeah, I think a main thing is that papers can't be the only benchmark for public goods research. It's not just citations. Like you got to be funding people
Yeah.
to make to make things that people use. To borrow something from the venture capital world, it's not something you worry about if they're paying for. And so these new NQI programs, new funding for quantum should include software components, and for that, some of the success should be users, contributors,
Yeah.
like that kind of stuff. And it's not something that these program officers are always so used to tracking, but it's trackable. If they have questions about how to do it, come talk to us. I'm willing to create a foundation.
And Ziyaad, same question for you. Any sort of, because you're coming at it from a broader sort of starting point, open source technology starting point. Anything from your perspective that would be a call to action for public policy that would help quantum at this stage?
I would say, and this is based on actual kind of conversations I've had with policymakers, which is don't be afraid. Do not think of quantum as, this massive security threat that needs to be under lock and key, because that was an argument put forward for AI and was resoundingly and continues to be resoundingly proven wrong as a result of, the move towards open weight and open source models. We need to have both, right? We need to be investing in the full kind of stack. And what I had seen earlier with quantum was this kind of fear of even talking about it in an open source sense, because the security implications were just not communicated effectively enough to policymakers along the lines of what open source actually enables. And so I would say tap your friendly quantum technologist and actually have the conversation on why it's important to build a vibrant community that can actually debug live, where you can actually be transparent about what's being put out into the field so that you don't create massive security choke points or critical flaws in one isolated container of the world.
That's great. Okay, so let's imagine for a moment the all of the calls to action in the paper and from Mozilla and from Unitary Foundations are heeded, and the world is perfect. What does the I know I said use your imagination.
That's right.
What do you think the quantum software landscape looks like in 2030 at that given that fantasy?
I love this question. I want Will to answer it. I want Will's full imagination of the future.
Me too.
Look, I think we have a world where there's a lot of companies competing to build better and better quantum computers, and there's a lot of companies competing to use them with a bunch of software, and that you can start a company in a garage that has a new way to use quantum computers. Because gosh, hasn't that been so impactful for normal computers? And so I want us to be able to do that for quantum computers too. And I think we're going to invent a lot of new stuff once we understand how quantum physics works better, and we can simulate things with quantum computers to make that happen. And I want young people from around the world who are super smart no matter where they live to, even if they don't have a garage, get on the internet and be able to start that company that uses quantum computers.
That's great. You mentioned the HPC example from the white paper. I think I'd close with what, in my mind, is the best example of an argument for open versus closed, which is von Neumann at Princeton Institute of Advanced Studies versus ENIAC. And when both systems were operational, if somebody asked von Neumann, how'd you build that? He'd run off a copy of the white paper, which was the entire spec. And there ended up being something like 50 or 60 clones of the IAS system. And if anybody even came close to the ENIAC system, they would sue them. And today we have von Neumann machines in our pockets, and who knows what the architecture of the ENIAC was? I don't. So the point that you made, I think, about openness being the best recipe for incredible value creation in the open, in the public markets, in venture-backed startups, in academic settings is, to me, like, it's incontrovertible. So I think the teaming up of Mozilla Foundation, Unitary Foundation is a great thing, and I want to thank you both for your time here today. It's been a great conversation.
Thank you, Sebastian.
So much. Appreciate it.
All right. That was Will Zeng and Ziyaad Bhorat on why open source infrastructure may be the most high leverage investment in quantum computing right now. A few things stood out to me from this conversation. First, Will's point that the funding isn't the end goal, the people are. The microgrant program, Unitary Hack, the community that's formed around these projects, that's the actual asset. The money is just the mechanism to get there. Second, Ziyaad's framing of philanthropy as catalytic capital, deploying resources at a high-risk stage to demonstrate that something works, not to capture returns. Mozilla isn't betting on quantum as a product, they're betting on openness as an intervention at a moment when the field's foundations are still contestable. That's a fundamentally different posture than what we typically see in this space. If this episode resonated with you, the white paper is linked in our show notes. It's a worthwhile read and a useful document to share with anyone in policy, philanthropy, or investment who's trying to understand where quantum is headed. The Unitary Foundation's microgrant program is open to quantum developers worldwide, and Unitary Hack returns later this year if you want to get your hands dirty with real open source quantum software. Links to everything are in the show notes at newquantumera.com. If you're not already subscribed, find us on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts, and follow us on LinkedIn and Blue Sky for updates between episodes. Also, if you go to the website, you can subscribe to the newsletter, which will feature occasional essays and other pieces of content from me. Thanks for listening. I'm Sebastian Hassinger, and this is the New Quantum Era.